All right, so we are rolling. Um, all right, any questions? So PA3 tomorrow morning at 8, right? So make sure that's uploaded and I've got reporter access so I can download. But any lingering questions? All right, so I mentioned in a note, right? We're gonna start picking up speed now, and going a lot quicker through things. So um, I'm gonna start talking about graphics today and how we do drawing on a graphical element using swing. So we've played around with placing objects like buttons and text fields, and started looking at how we do things like pick up mouse clicks and other interactions like that. But another aspect of working with swing and GUIs in general is being able to paint, being able to draw things on windows. And the way we do this is a bit unusual. It's very different from kind of our procedural approach that we use in most of our C programming, for example, where we say, do this, do that, check condition A, and do either B or C, and do this in a loop until something happens, right? That's not what our code is going to look like going forward. Most of our code is going to be event driven, which means we're not going to do anything until some event occurs. For example, somebody clicks a button, or somebody moves a mouse, or resizes a window. And when something happens, we're going to have set things up so that code executes in response to that. And our code that executes has to be ready to do whatever it's supposed to do. And so it's going to be a lot of setting things up, updating state information in our software so that when an event occurs, the correct actions are taken. And this is the way that most modern software tends to be wired. This is the way operating systems work, right? Your operating system doesn't really have a big loop which says, are you pressing a key? Are you moving the mouse? Are you hitting the power button? Are you clicking on a icon, right? That's not how your OS works. Your OS is mostly just sitting there saying, like, loop, go to loop. It's just spinning its wheels. But when you happen to, press a key or move the mouse or click on an icon, something like an interrupt is generated. And the OS has previously set things up so that when these software interrupts occur, certain pieces of code execute. Okay, and that's what we're going to be writing for really the rest of this course is basically interrupt driven code. Okay, but it's called event driven. It's a software interrupt. So that's going to be a difference from what we've been doing in C and what we've been doing so far for the most part in Java. Event driven versus procedural. And this business of painting on a graphical element is going to be sort of similar, because we don't get to say, I want to draw a rectangle, draw a rectangle for me right now. Okay, we don't get to do that. There's only one place where a rectangle can be drawn, and it's inside a method that we're not allowed to call. Okay, so it's really going to be, if we want to draw a rectangle, about setting things up in memory and then asking the system to call this thing that can do the actual drawing for us, and modifying that thing so that when it's called upon to draw, it finds the things we set in memory and says, oh, I think I'll draw a rectangle, and bingo, our rectangle appears. Okay, so let's jump into some code, and as we work with this, hopefully this will make more sense. So I've already fired up Eclipse. Photon is working pretty well. Let's start a new Java project. And I'm just going to call it, cool stuff, because this is pretty cool stuff. And I'm going to make a JFrame, and I'll call it main cool frame. And, as it is, we can run this and we get a frame, but there's nothing exciting happening here. Okay. So let's go to the design window, and we have basically two things that have been created for us. There's this JFrame, okay, which you know, is a Java Swing JFrame. And then inside it is this content pane. And the content pane is an object of type javax.swing.jpanel. Okay, and it's called content pane. And if I look at my source code, and I just search for jpanel, right? Here's where the content pane is declared to be a jpanel, and here's where the content pane is constructed. And that's what makes it so that when we run this main method, we see this frame. There's actually a content pane in here, a jpanel that just kind of, you know, looks the same as the rest of the frame, but there's actually a lot going on there. Okay, so here's what we're going to do. We're going to make our own version of a jpanel. And instead of making a content pane called jpanel, I'm going to call this my amazing panel. Okay, and my amazing panel is going to do some really cool stuff. It's going to paint some stuff inside that panel so that we get, say, a rectangle showing up. Okay, and right now, you know, it's complaining all over the place because my amazing panel doesn't exist. Okay, so let's create a class my amazing panel. Well, I could click on this to do it, but I'll just do it the old-fashioned way. Let's say File, New Class, and I'll call this my amazing panel. And I've got an empty class now. Well, that was enough to get some of my errors to go away. But look what's happening here. I'm trying to set the border, I'm trying to set the layout, and it's telling me my amazing panel does not have a method called setLayoutBorder. Okay, it does not have a method named setBorder. So before I can use this as a jpanel, I have to write all of those methods, right? So what methods do I have to write? Well, basically, I have to write possibly all of these methods, right? Which means all of these methods and all of these methods and all of these methods. And I need constructors for constructing with all of these approaches and so on and so forth. A lot of work, right? We're not going to do that. So this is where class extensions come in. I'm going to say my amazing panel extends a jpanel. And I'll take the shortcut here and say import jpanel. And now my amazing panel, guess what? It's got a setBorder method. It's got a setLayout method. Why? Because it inherits those from the jpanel. So my amazing panel really is a jpanel. And if I run this, it works perfectly. All right, there's my jpanel. It's not terribly different from what we had before, but this is my own class. And I can put things in here to change what this jpanel does. Okay, so the main reason we're going to do this is because we want to do some drawing. And the main way we do drawing is to use the graphics class. So graphics is a class that contains a bunch of fun-looking methods like draw 3D rectangle, draw arc, draw image, draw line, draw oval, draw polygon, draw rectangle, draw string, right? And then filled versions of some of these for filling in a polygon or a rectangle or an oval. Okay, so a graphics class lets us do all of this fun drawing stuff. Okay, and all we have to do is for a graphics object to say draw line or fill rectangle, and it should do that. But here's the problem. We don't have a graphics object. We can't just create a graphics object out of thin air and expect it to draw on this particular object, right? We've got to somehow have a graphics object associated with this jpanel. And we're not allowed to construct. But it turns out that inside a jpanel, there's a method called Paint. It actually comes from the JComponent class. And Paint is called with a graphics object. And so inside Paint, the code in that method can use this argument G to say like g.fillRectangle, g.drawLine. So if we were to write our own Paint method, then when someone is ready to draw the background of the JPanel, they would call my Paint method, and I could get my Paint method to do whatever I want to do. So drawing is as easy as this. Let's just make a public void paint with an argument of type graphics, which I'll import. And I'll just do a g.fillRectangle 100, 100, 200, 300. And that's got to be an uppercase R on rect. Okay, and what have I done? I've made a paint method. JPanel had a paint method. I've replaced it. I'm using my own paint method, and now when JPanel's paint method is called to draw the background of the JPanel to make it gray and so on and so forth, it's going to run this code instead. And so if I run this, I get a frame with a panel inside with this rectangle, which starts at 100, 100 and has a width of 200 and a height of 300. Okay, so sidebar, coordinate systems. Anybody taking linear algebra this quarter? Because this will be different. On graphical systems, almost always, our coordinate system looks like this. X goes horizontally from left to right. Y runs vertically from top to bottom. The origin is in the upper left. Right? And that's clearly backwards from how we're always taught coordinate systems throughout school. Normally our origin is down here and Y goes up. Is this wrong? Not at all, right? It's like a map of the world where north is on the bottom and south is on the top. It's a perfectly valid map, right? It's just not what we're used to. So all of these graphical systems, right, use this kind of coordinate system. So in our code, when we said let's put a rectangle starting at location 100, 100, that corresponded to a place pretty close to the upper left corner. 100 over, 100 down. And then these last two arguments, this is the width and the height of the rectangle. So 200 pixels across, 300 pixels down. And these are pixels, so my screen is 1080 by 1920, so 300 is about a sixth of the way across my screen. All right, and you can find documentation on all these methods. So right, so if you look at the fill rectangle method, X and Y are the X and Y coordinates for the upper left corner. It should say that somewhere. And then width and height are the width and the height. All right, and this only works because my method is called Paint. Now I could make a method called XPaint, and that's fine. I can make methods with whatever names I like. But when I run this, right, nothing is calling my XPaint method, so nothing is drawing a rectangle. Right? What paint method is being used? The one from the superclass, the paint method inside JPanel. But if I name this Paint, that replaces JPanel's Paint, and now this is what's being called. So let's keep track of how many times we're called. So So let's just make an integer variable call count. I'll initialize it to 0, and every time that I get called inside Paint, I'll bump up call count and I'll print that number out. Okay, so I'm going to run this and it says inside Paint call number 1. Watch what happens when I resize. Paint gets called a bunch of times. Now when I move, nothing happens, but when I change the size of this, right, it calls Paint. If I cover up part of this, it calls Paint. If I expose it, it calls Paint. So Paint gets called by something. Something that detects that this window needs to be redrawn. And we don't know exactly what might cause it to call, and that's okay. All we have to do is make sure that Paint will redraw this panel, right, the correct way anytime that it's called. And we can put whatever we want inside here. So we can draw a line from, I don't know, 50, 250 to 500 and 450. All right, so let's just draw a diagonal line. There's a diagonal line. So making graphical displays is about basically drawing lines and rectangles and circles and filling things and erasing things and placing the pieces to make whatever you want to appear. Alright, so we'll talk more about dealing with coordinate systems and things like that probably tomorrow or Thursday. But let's tie this into events. So if I go back to my design window, let me make this bigger so I don't have to keep resizing it. Alright, that's nice and big. So if I right click in here on my content pane, I can say add event handler. Let's add an event handler for mouse motion. And I'm just going to do mouse moved. And so this is going to be called whenever the mouse moves. So the argument to the mouse event arg0, which is arbitrary, you can call it whatever you want, comes with a pair of get methods, get x and get y. Let's just print those out, and now by just moving the mouse I can see x, y coordinates. And if I come up here to the upper left corner, you can see that's 100, 100, and this spot down here is basically 300, 400, and there's 50 and 250 and so on. 0, 0 is up in the upper left, and they extend down and to the right. Alright, so here's what I want to do. I want to draw a circle wherever my mouse goes. I want to take these XY coordinates and draw a circle right there. Well, when the mouse moves, I'll call this method, and in this method I can get the X and Y coordinates of the mouse pointer, and I can print them out. So would like to draw a circle at the point XY. Yes, you can definitely change the colors. There's a set foreground or a set color method. We'll play with that in a few minutes. Well, I may as well play with that now since we're already in here. Let's change the rectangle. So let's go back to graphics. So there's a set color option which takes a color and specifies basically the graphic context's current color. So what is color? Color is another class that mostly has a bunch of fields. There's color.blue, there's color.cyan, and so on and so forth. And you don't have to remember if it's uppercase or lowercase because they use both of them, right? So so I could say g.setColor color.red, right? This is a static, right? Red is a static object of type color, so I don't need to construct a color object. I can just say class name color.red. That'll set the color to red, and it should create a red filled rectangle. I have to import color from the abstract windowing toolkit AWT. And then our line, let's I don't know, let's make our line blue. So if I run that, red rectangle, blue line. Alright, so how do we tie this to the mouse? How do we draw a circle at the point x, y? Ideally, we could just say g.draw oval, x comma y comma whatever dimensions we want, 50 by 50, right? But we don't have this graphics object, this g, that we can use. And the only place we have a graphics object is in this totally different class called MyAmazingPanel inside this paint method. So what we're going to do is we're going to take the value x, y that we have here, and we're going to send it to this object, this content pane, and we're going to have the paint method read from that content pane method, that variable, right, to figure out the xy coordinates. So let me do this and it'll make more sense. So content pane is our panel, right? So I'm going to say content pane.save, and I'm going to pass x and y. So we'll make those available to our amazing panel. And I have to write this method save. And I'm just going to save these in some class variables. And this doesn't have to return anything, so it can be void. And I'm going to make last x and last y a pair of integers. And then down here, what am I going to do? I'm going to draw an oval at last x, last y, and I'll make it, I don't know, 40 by 40. Alright, so we got a lot of things going on here. Okay, we're going to click the mouse, and when we click the mouse, it's going to go into this mouse motion listener. Sure, we're going to move the mouse. It's going to go into this mouse motion listener. It's going to call this mouse moved event, which is going to read the XY position of the mouse, print them out, and then call save in the content pane. In the content pane, that save method is going to save those arguments into these class variables called last x and last y. And the paint method is going to use last x, last y to decide where to draw a circle, a 40 by 40 oval. So if I run this, I get a circle in the upper left corner, right? Why? Because my initial last x, last y was 0, 0. And this is not the center of the circle, this is the upper left corner of the circle. Go figure, right? But, you know, when I move the mouse, my code is clearly running because I'm seeing my xy's change down here, but nothing is changing in my display. But guess what? If I resize my window, there's my circle at the last place my mouse was. If I put my mouse down here and I resize, there's my new circle. So what's happening? Everything seems to be working correctly, except I'm only seeing the circle drawn when I change the size of my window, or when I maximize it or minimize it. Okay, so this is the next thing we have to deal with. We want this paint method to be called whenever you move the mouse. In addition to saving the X and Y coordinates for the content pane to use, what we'd like to do is for the paint method to be called. The problem is we cannot call the paint method because the paint method needs a graphics argument and we don't have a graphics argument. So what do? Well, inside the JPanel class, there's another method called Repaint. Comes from component. So what does Repaint do? It says add the specified region to the dirty region list. If the component is showing, the component will repaint it after all the currently pending events have been dispatched. Okay, what the heck does that mean? We cannot call the paint method directly, but we can say content pane.repaint. And this does not immediately call paint. It simply registers a request that paint be called. Okay? The reason it's done like this is because lots of things may be trying to paint on this J-frame. Lots of things are trying to paint on my screen right now. And they need to be coordinated carefully so they don't step on each other. So we don't just allow an arbitrary method to start painting on the screen. What you do is you make a request. You say, hey, call paint when you can. Okay, this is what happens when you resize a frame. A request is made saying, hey, this frame just changed size. There might be parts that are visible now. Please repaint this. And eventually something will call paint. So this will cause paint to be called. And now if I run this, I get this kind of effect. So every time I move the mouse, I not only update last X, last Y, but I register a call to repaint which says, hey, call the paint method. And when the paint method gets called, what does it do? It picks up that last X, last Y, and it draws an oval right there. And as my position changes, right, I get this kind of effect. And this alone is worth the price of admission, right? Because if you can do this all day, you got a good life. But did you catch what happened a moment ago? I resized this and everything disappeared. And I can draw all this stuff and I just make my window a little bit bigger and everything disappears, right, except that last circle that I drew. So what exactly is going on here? So here's the next detail. I'm actually doing something slightly wrong, slightly incorrect. There's a bug in my code, and the bug is giving us this cool effect, right, where we can see the image of all of the ovals that we've drawn. But that's an anomaly. All right, so what's going on here? When I draw a J panel, we always get this nice clean background. It's this sort of dark gray, and it's uniform, and it looks a certain way, and there's borders, and those borders might have, you know, some depth to them, some beveling, and so on and so forth. How does that happen? Because there's a paint method inside JPanel that does all of that. Well, we're not calling the paint method in JPanel anymore. When we ask to paint a My Amazing panel, this is the code that runs. And that's the only code that runs. And so there's no code executing to erase the back of the JPanel. And so we just see the ovals that were there. And so this is a cool effect, but it's a glitch. So what we really want to do is we should do everything that JPanel's paint method normally does. How many different ways can I spell paint today? We should do everything that JPanel's paint method normally does, and then do our own stuff. Draw the oval and so on and so forth. Okay? Well, we don't want to write all of the code inside JPanel's paint method, but turns out we don't have to. Right? What we want to do is we want to run the paint method from this class that we extended. And there's an easy way to do that, and that's to use the super keyword. So if I just say super.paint and I pass it the same argument G, that will run the JPanel paint method. Okay, this is the My Amazing Panel paint method. This says run JPanel's paint method because super says the super class, the class that we extended. And part of what the JPanel paint method will do is erase the background, put it back to that nice clean uniform gray color, and now we're going to draw one oval. And so if we run this, we've got what we were originally after, which was just a circle that follows our mouse pointer around. Now what if I want to center this circle at my mouse instead of having it be the upper left corner? This is analogous to something we're going to do a lot of in the next few days. So with circles or ovals, we picture a box around them. And this is our point XY. This is our radius R. This is our radius R. This is our radius R. So if we want the x coordinate of the center of our circle, it's the x coordinate of the upper left corner plus R. And if we want the y coordinate of the center of our circle, it's the y coordinate of the top plus this distance R. So if we draw a circle at xy, the center of the circle will be at x plus our radius, which is 20 in this case, y plus the radius. So x plus 20, y plus 20. So if we actually want our circle to be centered at x comma y, the coordinates we should specify should be x minus 20, y minus 20, or whatever the radius is. So let's make that a little adjustment, and let me make the radius variable, and instead of making this, I guess the radius is 40. Instead of drawing at last x, last y, let's draw at last x minus radius. Last y minus radius, and I don't actually remember if this is the radius or the width of the rectangle. So let's check. Draw oval. So height and width of the oval to be drawn, so that's twice the radius. So if we want a radius of 20, then we want the height and width to be 2 times the radius, 2 times the radius. So if I run that, I've got my circle. It still has a radius of 20, right? Width and height of 40, but it's centered at the tip of my mouse pointer. And now you can start to do all kinds of things, right? I could do something like radius equals, I don't know, let's just do last x plus last y over 5. Let's change the radius depending on where we are. And so now I've got, you know, something. So that's nominally fun. All right. Well, what about our colors? So let's leave the radius at 20. Let's play with the color. So in our color class, we have these statics like color.pink, color.white. We can also construct a color, and we can construct a color by passing three integers, R, G, and B. These are the intensities of red, green, and blue that we want to mix. Okay, so for light, your primary colors are red, green, and blue. Okay, for pigment, they're different, but for light, it's red, green, blue. And these intensities are integers from 0 to 255, so 8 bits each. This is why 24-bit color is a thing. We can create a color object by specifying the amount of RGB that we want. So let me do this. Let's make integer red, green, blue. Actually, let me make these class variables. And let me initialize these to 0. And let's just do something weird, right? Let's just mess with these. Let's just set red equal to red plus 7 modulo 256. So I'll just bump up the amount of red, and if it gets to be beyond 255, I'll roll it back over to 0. And I'll just bump up green by some amount. And I'll bump up blue by some amount. And I'll do g.setColor, and I'll make a new color composed of red, green, blue. You can experiment with this, right? There's lots of fun to be had. But we're just sort of tweaking the red, green, and blue guns as we move around. And you can see here it's kind of a light blue, and here it's a dark blue, and purple, and very dark, and so on. All right, but this is not as fun as what we had before, where we had all of these ovals persisting, right? Because our paint method, it clears the background, and then it draws these shapes. Now, if we get rid of, yeah, we could fill them too, and that would look better. But I'm going to take the cheap approach. I'm just going to get rid of this call to the super classes paint, and go back to where our shapes persisted. Okay, and so we get this nice rainbow effect like that. Okay, but that's not really the right way to do this. It looks a whole lot cooler, but you know, it's kind of an anomaly, because every time that we resize the window, it goes away, and other things can go wrong as well. So let's do this the right way. Okay, let's keep calling the superclass constructor, but let's keep track of the ovals that we've drawn. So how are we going to do that? Well, we have to save them somewhere. And this is another aspect of all of this stuff we're going to do, including PA4, which we'll post in about 20 minutes. We're going to basically update stuff in memory, and then the paint method is going to read from memory and use what it finds to do some drawing. Okay, so I'm going to make a linked list. I'm going to make a list linked of points. And I'm going to need to import the linked list class, and I'm going to need to import the point class. And point is just another class that basically has an X field and a Y field, which we can read, and we can also say, you know, get X and get Y, and so on and so forth. It's basically just like a structure in C that holds a pair of integers. but that makes it a little easier to build a linked list of them instead of trying to make two linked lists of X and Y. So points is a linked list of these points things, right? And down here in our save method, here's what I'm going to do. I'm not going to worry about last X, last Y. Instead, I'm going to make a point which corresponds to the new mouse position. So I'm going to construct this point object, and then I'm going to add that to our linked list. So now I'm going to say points, which is a linked list. I'm just going to add P to it. All right, so what am I going to do down here? I'm going to make a loop. So let's draw all the circles from our linked list, which is called points. So linked list come with a size method. And for each of those, okay, I'm going to update my red, green, blue color as before. I'm going to set the color. And then I'm going to say, let's set last X equal to points.getI. That's a point, and it has an X field, so I'll get the X field. And I'll set last Y equal to our linked list getI, and I'll get the Y field of that. And then I'll do exactly the same thing as we did before, which is use those XY coordinates to draw an oval. So now if I run this, we're back to our old behavior. And it looks pretty weird because every time that I do this, it's redrawing all of my shapes. Right, so the colors are changing. And that's pretty weird, but it's kind of cool. Alright, now if I set red, green, and blue to 0 before I begin this loop, and then I come in here, now we're back to where we were before, right? Because the color of the first object is always the same, the color of the second object is always the same, and so on. I'm curious what this looks like if we fill it instead of drawing it. So if we do filled rectangles, it looks like that. That's pretty cool. That's really cool. Good suggestion. All right. Well, one thing that's happening here is I'm chewing up my memory, right? My linked list is growing and growing. Every time I move my mouse, I create a new point that I add to the end of my linked list. My linked list is getting bigger and bigger. Eventually, this will crash. And it will crash because my JVM runs out of memory, and that's a really bad way to go. So let's preserve memory. So in our save method, let's just say 50 things. So if the size of our linked list is bigger than 50, we can call the remove method. The remove method removes the first element of the linked list. So we'll start adding things to our linked list. Once we have 50 things on there, if we add a 51st, it will get rid of the first thing. So our linked list will always be 50 elements in length. And so by just adding that one if statement, we get a completely different behavior, which is we have this moving worm of 50 circles, but you know, if I move slowly, that takes up little space. If I move quickly, it takes up more space. Right? So we got this kind of stuff going now, all for a few lines of code, which is pretty cool, right? And what did we write? We wrote a save method using a linked list. We wrote a paint method, which is basically just, you know, a for loop that pulls off points and fills an oval. That's really it. And then in the mouse handler, we just made one call to save using the getX and getY methods of this argument, and that's it. Everything else was written for us, right? But we've got, you know, something kind of cool, something we could show our friends and say, yeah, I'm a computer scientist. Look at what I can do, right? And they'd probably be suitably impressed. So this is part of the nature of working with graphical elements, right? It's really good on the kind of mostly instant gratification aspect, and that makes it fun, right? All right, so PA4, it'll open at 3 o'clock, and we'll talk about it in detail tomorrow, but it's basically going to be a game. So I'm going to have you code up the game of dots, and it's going to require drawing a playing field, responding to mouse clicks, updating what you're drawing, and then doing some analysis on what you've drawn. And it's really going to bring in all these different aspects of event-driven code, thinking about the data more than the actions, right? We're going to mainly be working on a game that updates data structures in memory, but then we're going to add a paint method that gives us a visual representation of what we've updated. And this is stuff that you will see in Android development, you know, iPhone apps, most applications that you typically encounter today tend to be the same kind of thing. Android has, you know, the same thing. There's a paint method. Instead of repaint, you call invalidate. But it's the same basic structure. So you'll see this stuff a lot. You'll see this stuff at a university, in other courses. So, and it's frankly a lot of fun to play with. Just jump in there and get your hands dirty. So this morning's code I posted up on the Canvas link already, and you can modulate that if you like. All right, so that's a good sort of plunge into the world of graphics that we're moving into. Go ahead and finish up PA2. Make sure that's readable and, you know, updated by 8 a.m. tomorrow, and then we'll move on to PA4 starting tomorrow. All right, have a great afternoon. Enjoy the sunshine. Catch you next time.